Hello students, in today's video I am going to discuss the concept of integration by partial fractions. In order to discuss this particular concept, I will be discussing few more things here. A function is written here px upon qx, where px and qx are the polynomials in x, and this denominator is non-zero, qx is non-zero. So students, this type of function is known as px upon qx is known as a proper rational function if one condition is provided here. What is the condition? If degree of px is less than degree of qx. So along with such type of condition, this particular function is known as proper rational function. And for proper rational function, we can easily apply the concept of partial fraction. But now students, whenever improper rational function is provided, then how to deal with it? Then we will apply the concept of long division process. Long division process. By the long division process, I can write any improper rational function in terms of proper rational function. I mean to say, this particular improper rational function px upon qx can be written as tx plus p1x upon q1x, where tx is any polynomial in x and this p1x upon q1x is a proper rational function, and proper rational function means degree of p1x is less than degree of q1x. After that students, for some proper rational functions, a chart is provided here. And for all these type of proper rational functions, how to write the partial fraction, that thing is mentioned here in this chart. So suppose here first type of function is px upon q upon x minus a x minus b. So its partial fraction is a upon x minus a plus b upon x minus b. For second type of function, it is a upon x minus a plus b upon x minus a whole square. For third type of function, it is a upon x minus a plus b upon x minus b plus c upon x minus c. For this fourth function, it is a upon x minus a plus b upon x minus a whole square plus c upon x minus b. And for this last type of function, it is a upon x minus a plus bx plus c upon x square plus bx plus c. So now students, this whole concept will be clear to all of you with the help of few questions. So that is why I have solved here one question. In this question, we have to evaluate integration of 1 upon x plus 1, x plus 2 with respect to x. That is integration dx upon x plus 1, x plus 2. So for that purpose, I have extracted this function only 1 upon x plus 1, x plus 2. So it can be written like a upon x plus 1 plus b upon x plus 2. So by taking LCM of this term, it will be in denominator x plus 1, x plus 2, and here it would be like this. And then by some simplification, we can write it like 1 upon this particular term 1 upon x plus 1 x plus 2 is equal to a plus b x plus 2a plus b. So by comparing these terms of this particular equation, we will be getting this equation, and after that what we can do, this 1 can be written like 0 into x plus 1. So by comparing the coefficients of x and then comparing the constant coefficients in this equation, we will be getting two equations. A plus b is equal to 0 and this 2a plus b is equal to 1. So that is what I have done here. So by solving these two equations, I will be getting a equal to 1 and b equal to minus 1. So ultimately we were dealing with this particular equation, this particular term, I mean to say 1 upon x plus 1 x plus 2 is a upon x plus 1 plus b upon x plus 2. So what I have done here, I have replaced the value of a here, that is 1, and replaced the value of b here, that is minus 1, and then I have taken the integration. in both sides of this equation. So as we know, integration of 1 upon x plus 1 is log mod x plus 1, and integration of 1 upon x plus 2 is log mod x plus 2 and plus constant of integration. Or we can also write it like log of m minus log of n is log m by n. So that is what I have written here, log of mod x plus 1 upon x plus 2 plus constant of integration, and it was the actual value, the final value of integration 1 upon x plus 1, x plus 2, and with respect to x. So in such a way we have dealt with this particular question. Now students, thereafter one more example I have solved here, but in this example, as you can see, the function given is not proper function, not proper rational function, it is improper rational function. Improper rational function, why? Because here degree of numerator is not less than degree of denominator. So what we will do here, we will apply here long division process. So by the long division process, I can just convert this improper rational function into this proper rational function. How? So for that, I have divided this numerator by this denominator here. So if we will divide this x square plus 1 by this x square minus 5x plus 6 one time. So one time, I mean to say, again I have written it here, and then I have subtracted it. So if we will subtract it, here we will be getting 5x minus 5. So that is what I have done. I have written this particular improper rational function like 1 plus this upon this, that is 1 plus 5x minus 5 upon x square minus 5x plus 6, or 5 is common here, and inside the bracket x minus 1 upon x square minus 5x plus 6. And you can observe here, this is improper rational function, but here it is the proper rational function, because here degree of numerator is less than degree of denominator. Now since students, it is a proper rational function, so we can deal with it separately with the help of partial fraction. So this x minus 1 upon x square minus 5x plus 6 can be written like x minus 1 upon x minus 2 x minus 3, and then it can be written like a upon x minus 2 plus b upon x minus 3. So by taking LCM, we will be getting this particular equation, and by comparing, I mean to say, these two terms of this equation, we will be getting this particular equation here. So from this equation, what we will be getting, on comparing coefficients of x and on comparing the constant terms, we will be getting here two equations, a plus b equal to 1 and minus 3a minus 2b minus 1. So by these two equations, we will be getting the values of a and b. A will be minus 1 and b will be 2. You can also verify it later on. So now students, since we are having the values of a and b, so in this particular term, actually this particular term equal to this one. So x minus 1 upon x square minus 5x plus 6 is what? It is a upon x minus 2. A is minus 1 upon x minus 2 plus b upon x minus 3, that is 2 upon x minus 3. Or you can write it 2 upon x minus 3 minus 1 upon x minus 2. So what we will do now, in this equation 1, we will be utilizing this value. This value, I mean to say, this value which I have separately evaluated here. So this value we will be utilizing here in equation number 1. So by doing this, we will be getting this x square plus 1 upon x square minus 5x plus 6, its integration, and integration also I am taking here in this equation in LHS and RHS. So it will be integration 1 dx plus 5 into integration of what? Integration of this particular term, and then integration of dx is x here, and plus 5 and 2. Integration of 1 upon x minus 3 is what? It is integration of 1 upon x minus 3 is log x minus 3 in mod, and integration of 1 upon x minus 2 is what? It is log mod x minus 2. So that is why we can write it here like x plus 5 into 2 10 log mod x minus 3 and minus 5 log mod x minus 2 plus constant of integration, and ultimately this is the value of this particular integration. So students, in this particular video I have discussed two questions. In one question directly proper rational function was given, but in another question directly proper rational function was not given, improper rational function was given, which was converted into proper rational function. So students, I hope that this video will be very helpful for all of you to understand the concept of integration by partial fraction. Thank you so much for watching this video.